Okay, now we are going to look for multicollinearity. For example, if two variables are always identical, then they have a problem where you can't tell which of the two variables is causing the relationship. First thing we have to do is, since we're trying to do over time, we have to insert the time. So I right click, insert, entire column, time, and we look down like last time. It's the same, so negative 49.5, negative 48.5. If you don't know how to do this, look at the previous video for this week. Now let's run the regression. So we go to data, data analysis, regression, and it has stored in the regression that I had before. That's E1 to 101. So regression 1. And we've got poor adjusted R squared, excellent significance of F. We only have income as significant. Let's check for multicollinearity. So we do data analysis. The check for that is correlation. You want to do the correlation matrix. Click OK. Go choose the variables. And you don't want to include your y variable, because actually having multicollinearity with the y variable is desirable. That says it's moving the same way or the opposite way as your y variable. Then output range, put it there, click OK, and we look. What do these numbers say? This 99.998 is saying that there's a 99.8% probability that the variable is changing in the same direction. That is not good. You want the variables to be unrelated. This income says there's a high probability that it's related but in the opposite direction, so that as time goes on, income goes down. Well, the sign's unimportant. It's not as good as we'd like, but it's definitely acceptable. Same thing with this negative 0.51. We want numbers, absolute value of the correlation coefficient to be less than 0.8. That's what we want. These two are less than 0.8, this one's not. So we have to rerun the regression without a variable. Which variable? Well, economic theory look and say, well, which variable is the least important from economic theory point of view of time and price, because we're in the time column and price row. Time is going to be least important for their sale, for demand. So we want to get rid of time. If we decided to get rid of price, we would have had to swap columns, because you would need two variables that are side by side. So let's run the regression again. The y is the same as before. The x, we don't want column B, we only want C and D, so we can just change that to C. And then we can change this to regression 2. All I did is just eliminate column B and regression 2. Let's see what happens. Your adjusted R squared goes to 0.355, had been 0.348, slight improvement. The old regression had e to negative 9, the new one has e to negative 10, slight improvement. The new one has intercept is not significant, price is 0.36, income is negative 8, and I'm concentrating at 0.36 for a reason. Notice the price had been 0.8. Why? The computer couldn't tell whether the time or the price was what was determining the relationship. So it said, basically it looks to me like it's unrelated. Where here it's saying there's a small possibility it is related. It's probably not because that's greater than 0.1, but you're closer to being significant. And the reason is because the correlation between those two variables. You do not want multicollinearity. This gave us better results.